Hello everyone, in this video we will go through review questions for chapter 6. Question 1. Suppose a population can be described with the normal distribution with mu equals 20 and sigma 1.1. In this example, mu is when describing a population, we're actually talking about a parameter. And a survey is conducted of 300 likely voters. The proportion equals 0.52 for a particular candidate is an example of, we're also talking about a sample here. So we're basically talking about a statistic. Question 3. Interest is in estimating a population mean. Which of the following sample sizes would have the lowest variability in the sampling distribution? The lowest variability is associated with the largest sample size. Question 4. Radio talk shows often report opinion polls based on tens of thousands of listeners. These sample sizes are typically much larger than those used in opinion polls that incorporate probability sampling. Does a larger sample size mean more trustworthy results? Larger sample size mean more trustworthy results? Yes, if sampling is done randomly. Question 5. Compute the mean and standard deviation of the sampling distribution of sample mean when you plan to take a simple random sample of size 64 from a population with mean 44 and standard deviation 16. So we basically know the mean for sampling distribution is basically equals to the mean or mu of the population, which is 44. Also, in order to get the standard deviation of the mean of sampling distribution, we can divide the population standard deviation by square root of n, which is 16 divided by square root 64. 16 over 8 equals 2. Incomes in a certain town are strongly right skewed with mean 36,000 and a standard deviation 7,000. A random sample of 75 households is taken. What is the probability that sample mean is greater than 37,000? Probably the sample mean is greater than 37,000. So in order to get the z and calculate the p from population, mean, and standard deviation, we have to make sure if the sample distribution is normal and is basically if the distribution is normal, or if the sample distribution size or the sampling distribution, the sample size is over 30. So it says it right skewed, so we're not sure. So it's basically not normal, but we have n as 75. So we can use, so we have the condition to use the formula to get the z. In order to calculate the z, we basically just simply put x bar 37,000 minus mu 36,000 divided by standard deviation 7,000 of population divided by the sample size, square root of 75, 1.24. I just put the final result and to save some time. In order to get the z value from the z-score, we can use table A2. Here 1.24 equals to 0.8925. So p x bar, the p for z equal 1.24 So since it's 0.8925, but in order to get the in order to get the p, we have to use the complementary rule, and we basically subtract this value from 1, and it's equal to 0.1075. The contents, question 7. The contents of bottles of beer are normally distributed with a mean of 300 ml and a standard deviation of 5. What is the probability that contents of an individual bottle exceeds 303? So again, probability that X bar exceeds 303 ml. Again, we can use the complementary rule and use the z value, the z score table for X bar less than minus 303, which is basically 1 minus p X bar greater than 303. In order to get the p for X bar 303, we have to check two conditions: if it's normally distributed, and if it's n, if it's normal, and second, if n is greater or equal 30, it is normally distributed. So we can use the z formula to get the z score. It will be 303 minus mu 300 divided by standard deviation of 5 divided by 5. I will just simplify to save some time. It will be the z value for, it's just 3 divided by 5, and the z value, we can get the value for the z score from table. It will be 0.7257, and the probability would be 0.2743. Question 8. If you choose a simple random sample of size n from population with a given proportion p and compute the proportion p hat of the sample, then which of these answers are correct? Sampling distribution of p is approximately normal provided np hat and n times 1 minus p hat greater than 15. So this can be true. This is right. This is the correct answer. Mean of the sampling distribution of p hat is equal to p over n. Note the mean is the expected value of p hat, which is p. The standard deviation of sampling distribution is np times 1 minus p, but the right form is p times 1 minus p divided by n, square root of this value. The sampling distribution of p hat is closer to a normal distribution when n is very small. We know it will get closer, the sampling distribution will get close to normal distribution when n is large, or n basically greater than 30. The sampling distribution of p hat is left skewed for values of p hat less than 0.5 and np greater than 10 and n times 1 minus p greater than 10. So I put this description here. These conditions are generally used to ensure that the normal approximation to the binomial distribution is appropriate. The shape, if it's right skewed or left skewed or normal, it depends on various factors. It will just, these criteria will just help us to guess if it's close to normal approximation, if normal approximation is close to binomial distribution. Question 9. Suppose the salaries of teachers in your city are normally distributed with a mean of 50,000. Mu is 50,000 and a standard deviation of 5,000. Suppose we take samples of size 25. N equals 25. Find the probability that sample mean of salary will exceed 52,000. So again, here we have to see if the criteria, if the problem with two criteria: one, if it's normal, or the sample size is greater than 30. Here it states that it's normally distributed, so we can simply use z as x bar minus mu divided by sigma divided by square root of n. Find the probability that sample mean salary will exceed x bar exceed 52,000. In order to get the p the probability of x bar exceed 52,000, we can use the z value. We can use the z score table when we get the p for all the x's less than equal 52,000 minus 1 according to complementary rule. So in order to get the z and get the p-value for x less than 52,000, we just simply plug in the values in the formula. Z will be 52,000 minus 50,000 divided by 5,000 by square root of 25, which is 2. Using table A2 to get the z as 2. To get z score as 2, the z value would be 0.9772. 0.9772. In order to get the p greater than the probability for x bar for the sample mean that exceeds 52,000, we simply subtract this value from 1, and the probability would be 0.022. B. Find the probability that sample mean salary will be less than 47,000. Less than 47,000. P for x bar less than 47,000. Here we don't use the complementary as it meets the criteria, and we can get the z score for the z value for the z scores corresponding to the values less than 47,000. So we simply, here we have 47,000 minus 50,000, yeah, 50, Again, 5,000 divided by 25, it will be minus 3. The z-value for minus 3, we will use negative z-score minus 3 The probability would be P for x bar less than 47,000, be 0.0013 or 0.13%. C. Find the probability that the sample mean salary will be between 52,000 and 53,000. Px will be between 53,000 and 52,000. We just have to get all these probability and then subtract them. So first let's calculate the 53,000 minus 50,000 divided by 5,000 divided by square root 25. Here it will be 3. And for the 52,000, it will be 52,000 minus 50,000 divided by 5,000 divided by square root 25. It will be 2. The z-value for our z-score 3, we will use the positive z-score here. $99.87 $99.87. Here we can write $0.9987, and the z-value for z-score 2, 97.72. 97.72, and if we subtract this value from this value, vice versa, 99.87 minus 0.9772 is equals 0.0215. This is the answer for 3, or just 2.15%. Thank you so much. We'll see you in next video.